Hello everyone, welcome to EE101 channel, sharing industrial news and knowledge about residential and commercial PV inverters. I'm Rachel. Today we are going to talk about which inverter is the best to work in low DC voltage. There are many voltage values in the photovoltaic inverter parameter. One may be confused of what these voltage values accurately mean, what the correlation and functions are in practical application, and which voltage value is worthiest of our attention. Today, we will dive into these voltage values in the photovoltaic inverter. 1. Max DC input voltage. The maximum voltage allowed by the DC input of the inverter refers to the highest of strings of DC input, and not the sum of all string voltage. For example, if you have 20 panels, each one panel has an open circuit voltage of 40 volts. When you divide these panels into two strings, then 10 of a string, 10 plus 40 is equal 400 volts. So your maximum voltage is 400 volts. If you divide these panels into 4 strings, then your maximum voltage is 5 times 40 voltage, means 200 volts. When the inverter detects the maximum voltage and decides the set allowable input voltage, it will not start to work to MPPT voltage range. MPPT voltage range means that the MPPT module of the inverter can operate normally only within the DC voltage range required by the equipment. 3. Rated grade output voltage. The AC output voltage should meet the requirement of the local power grade for MPPT voltage range of full load. Within a certain voltage range, MPPT module can work with maximum efficiency. 5. The startup voltage of inverter. The inverter will start working when the highest voltage of DC input strings reaches the lowest starting voltage. 6. The shutdown voltage of inverter. When the output current and the voltage of DC input strings become weaker, which results in the output power of the inverter to be close to zero, then the inverter will stop working. In the photovoltaic power generation system, the solar irradiance gradually increases from sunrise. The voltage generated by the power generation module also increases slowly. When the voltage reaches the working voltage of the inverter starts to work and the whole system enters the power generation state. When the photovoltaic panel's voltage continues to rise and reaches the voltage operating range of the inverter MPPT will adjust the voltage to the maximum power output point voltage so that the string of panels tracked at each MPPT generates the maximum power. The situation remains the same from noon to evening. As the solar irradiance decreases, the voltage of the photovoltaic panels decreases. When the voltage is lower than the lowest operating voltage of the inverter stops running. The operating voltage range determines the start and stop time of the inverter in the daytime. Similarly, the full load MPPT voltage range determines the full load operation time of MPPT. The wider the range, the higher the power generation efficiency of the inverter. When you decide the size of your photovoltaic system, that is, calculating the number of modules in series in your home, 2 voltage values must be taken into account. 1. Maximum DC voltage allowed on the DC input of the inverter. 2. Voltage range of MPPT. So how do the two parameters work together? Taking Australia as an example, we need to consider the DC input voltage, and the following points should be noted. A. AS 477.2 has stipulated the DC voltage of household system should be no higher than 600 watts. B. The mainstream photovoltaic panel's maximum DC series voltage is 1000 watts, and with the development of technology, this value is constantly rising. C. The maximum DC voltage that can be carried by the DC wire. D. Maximum DC input voltage of the inverter. Only when the DC input voltage meets the above 4 requirements can it be included in the calculation of the number of photovoltaic panels installing on your house. So there are parameters that can easily to be ignored. D. Inverter startup voltage and shutdown voltage. As mentioned above, the starting voltage is when the photovoltaic panel reaches a certain voltage, which results in the power generation of the inverter. Therefore, inverters can start work when the MPPT starting voltage is not reached. The inverter can still generate electricity, but at this time it does not get the maximum power generation efficiency from the photovoltaic panels. As to say, the electronic energy grab from the photovoltaic panels to the inverters may have a certain loss because the photovoltaic panels did not work at the maximum power point. But in actual installation and application, our inverter is a very complex semiconductor electrical equipment. The installation is commissioned and tested. This works require a considerable amount of time and include labor costs. In the previous articles, we have mentioned that in developed countries, the installation of photovoltaic system needs to be finished by licensed electricians, and the labor costs are particularly high. Therefore, a considerable brand of inverters need a long time to adjust and connect to the network. Because they do not have LCD screen and buttons to achieve the adjustment, and their Wi-Fi logger doesn't have Bluetooth. Under this condition, the installer needs to take 1 to 2 extra hours to complete commissioning and testing, even spending an actual night until the sunrise to check that the inverter can start to work again before finishing the job. This may leave an impression that your teams are not professional. Why do you spend so long on installation and commissioning? Is the inverter not good? On the other hand, the amount of power generated by solar power system is positively correlated with the grid connected working time of system. Under the same condition, the earlier the inverter starts up and connects to the grid, the higher the power generation. For example, in the same summer, one inverter can usually start up and be connected to the grid at around 5 a.m., but another inverter may start later or even 2 to 3 hours later than the other. So let's make a comparison of the startup voltage and shutdown voltage of mainstream inverter brands. To sum it up, the startup voltage and shutdown voltage of the inverter, as well as the MPPT voltage range of the inverter, play a crucial role in the working time and working performance of the inverter. Through the comparison, HE Energy has excellent performance in the actual installation. HE Energy can start up at 40 watts and shut down at 30 watts, providing customer with more benefits and for the installer to get more time to finish the installation, saving labor costs for the retailer or wholesalers. Meanwhile, HE Energy has shown unparalleled flexibility when adapting to different types of roofs. So that's all. Please follow us on YouTube and Facebook. Thank you.